Hello everyone, for this tutorial video, I would like to formally define what it means for a function to be continuous. Mathematically, a function is continuous if the limit from both sides is exactly equal to the literal evaluation of the function at that point. And so, we can state it is continuous in a range of points or an interval, if this holds true for every point within this interval. You may remember seeing this exact definition when I was teaching well-behaved functions, and in fact, I was simply referring to the functions as well-behaved, because I wanted to save the more technical term for it until later. But they both mean the same thing. It makes sense for the technical term to be continuous because the function continues from either end if it is continuous at a point. Similarly, if there are any breaks in the graph, they are called discontinuities because of the fact the function is no longer continuing at that point. For example, given this graph, we would state it is continuous at x equals 0, but it has discontinuities at x equals 3 and negative 2. But the difference is, at x equals negative 2, the limit does not exist, because the function has two values from either end. But at x equals 3, the limit does exist, even though the function has a discontinuity. This type of discontinuity, where the limit exists in finite, is called a removable discontinuity for this reason, as a reference to the function being removed at that particular point, or moved to a different value. We can get a more informal and less mathematical definition of continuity as the ability to trace a graph from one point to another without picking up your pencil. Now that we know what continuity is, we can do things such as determine where functions are not continuous, such as this function, which would have discontinuities where the denominator is 0, so that is where t equals 5 and where t equals negative 3 after factoring it. We can actually evaluate even more limits than we could before, now that we have both an informal and mathematical definition of continuity, by stating that if function 1 of x is continuous at x equals b, and the limit of function 2 equals b, then we can state the limit of a composite function, or the limit of function 1 of function 2 of x, is exactly equal to the function of limit of function 2 of x, i.e., we can isolate away the limit on the inside, because of the fact that the first function is continuous, so the limit is equal to the literal definition of the function. So if we were asked to evaluate the limit as x approaches 0 of e raised to the power of sine of x, we would see that function 1 is e, function 2 is sine of x. So we take e out of the limit, we have e to the power of limit as x approaches 0 sine of x, and the limit as x approaches 0 of sine of x equals 1, which we can tell from consulting its graph. Therefore, we plug in 0 for this limit, e to the power of 0 equals 1. That is our final answer for the limit. Another thing that continuity helps us figure out is something known as the Intermediate Value Theorem, which is that if function 1 is continuous from point A to point B, and we pick any arbitrary number which we denote capital N between function at point A and function at point B, then there will be a third number c that satisfies being in between a and b, and whose function is equal to the value m. We can see graphically what this is talking about by seeing that the function will equal capital M somewhere between a and b, the endpoints of our intervals. And it doesn't matter what capital M is, it can be any value, and the theorem will still work. Because of the definition of this theorem, we cannot compute what exactly capital M is, we can only state it exists. It also has no guarantees about how many times capital M will repeat. It could be 1, 3, 5, 7, etc. for all we know. It all depends on the interval chosen and the function in question. We can use the Intermediate Value Theorem to determine the existence of roots, or places where a function equals 0. If we know that 0 is in between, the function evaluations at either end of the interval. For example, if we are given this function, the interval -1 to 2, and we want to show that it has at least one root, we would first compute the function at either end, and we can see that 0 is between these evaluations. And because we know the function is a polynomial, it is continuous everywhere, so it will be continuous regardless of the interval we pick. And so in conclusion, the function must have a root between -1 and 2, as the function must equal 0 between these two endpoints. We can see, if we look at a graph of this function, that our guess was correct too, although unfortunately we do not know what the exact value of the root is. We only know it exists at this point. If we are given a non-polynomial function such as this, and the interval 0 to 5, and asked if the function is equal to 10 or -10, we would evaluate the function at either end of the interval, and see that 10 is between these, so it fits the intermediate value theorem, because we also know the function is continuous. And although we can see that function of x equals -10 is not between these two evaluations, it does not necessarily guarantee that a root won't exist, because of the fact the root can be on another interval, as the functions are continuous everywhere. Now that we have given a more in-depth examination of what continuity actually is, we can move on to the last part of basic limits, which is the formal, literal definition of what a limit is, and how you can use it to prove that the limits have the value. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.